Hello and welcome everyone. If you are not 100% certain that your AWS API applications are TLS 1.2 ready, then this is the right session for you. Because 99.9% sure is probably not how you want to be responsible for keeping your applications up. We will talk about how to know if you're good to go, meaning you will be able to continue to connect to AWS. Or if you're not so good, we will also cover some simple remediation steps you can take to fix your application. I'm Janelle, and over to the right is my partner Daniel, and we were going to go over next what we will cover with you today. So looking at our agenda. For today's session, we will be talking to you about our current TLS deprecation effort, meaning we're going to modernize the TLS implementation on all of our AWS API endpoints. Now this work has already started and will finalize in 11 months, so the clock is ticking. We are splitting this talk into two parts. First, I'm going to be covering what is this current work we are doing, why we are doing it now. I will talk a little bit about TLS and the shared responsibility model. And I will also go over the TLS connection workflow and a bit about TLS negotiation so we can fully demonstrate how our current work can pose a risk of availability impact to you. I will then hand off to Daniel, who will go through how to know if you're impacted, what to do if so. He will cover a few advanced scenarios that you want to be aware of, just in case, and provide a demo on how to find and verify fixes in your applications to prevent any impact. So let's get started. Like this dad changing their adorable baby, let's talk about what AWS is also changing in regards to our TLS implementation. Now, in response to evolving technology and regulatory standards, we have announced a TLS deprecation effort, which means we will be ensuring only modern TLS, meaning TLS versions 1.2 and upwards, can be used when connecting to our APIs. This is a global change affecting all AWS APIs, all AWS services, and we did recently announce this just about a month ago in an AWS security blog post that we posted on June 28th. Now we will be making these changes gradually over the next month, or next 11 months, pardon me. So we will be doing these changes on a service by service basis, but once we hit June 28th, 2023, this will be the last date that you can use TLS 1.0 or TLS 1.1 to make a successful connection to our APIs. Now, fortunately, this only affects a small subset of you. I will go into this in more detail in the later slides, but just important to know. Now, we've talked about what is changing. Let's cover a little bit about what is not changing. I also want to highlight that we are not changing the endpoints that you, our customers, own. If you are running your own APIs built using our AWS services, you may have built them using API Gateway, any of our load balancing services, or you have your own CloudFront distribution, you fully own the TLS configurations for these endpoints that you own. The only thing we are changing is the TLS configured on the endpoints for our AWS services. Now, we encourage you to go ahead and update those, but this is not required. This is fully up to you. The other thing that we are also not changing is we are not touching certificates. So there are no changes to the X509 certificates that you are using for your TLS connections, and there are no changes to the chain of trust. Again, we are only changing the TLS versions that you can negotiate. Next, I want to go over a bit more on the context of these planned changes by looking at our TLS history. Now, as you can see, originally TLS was known as Secure Sockets Layer, or SSL. And it's still fairly common to hear someone say or use SSL just out of habit, even when the underlying connection is technically using TLS. Now you can also see that not only has the name changed, also the versions have evolved over time. So just taking it from the beginning here, looking at SSL v2 and SSL v3, developed in 1995 and 1996 respectively by Netscape. So Netscape originally created these versions, and they were the first widely used network protocols to enable cryptographically secured communications on the internet. Netscape then handed this over to the IETF, where it is now publicly owned, and because SSL was trademarked, the name became TLS. So starting with the first IETF version, which is surprise, TLS 1.0. So this was published back in 1999, and then came TLS 1.1 in 2006. Now these have both been officially deprecated as of March of last year. However, AWS has historically continued to support these for backward compatibility purposes for our customers. But now this is changing. We are giving you 11 months. We also want to note we have deprecated support for SSL v2 and v3 many years ago, with v3 getting deprecated back in 2016. Now when we refer to modern TLS, what we mean is TLS version 1.2, published in 2008, and TLS version 1.3, published in 2018. These are the only two versions that we are going to support on our service endpoints when we complete our work. Let's talk a little bit about why we're making these changes now. Why we think now is the right time for two primary reasons. First, many of you, more and more of you, frankly, are asking us to make this change. So we recently had a fairly large customer in a call not too long ago say, we don't even want you to figure out what applications might break. Just make the change. Go ahead and break us. Just do it. Now, these are global settings, so we're not going to take that drastic measure, and we are giving you 11 months to make this change because it would impact all customers. But just to show the passion that some of our customers do have about us completing this work. Secondly, and I mentioned this earlier, that another reason why we are making this change now is that less and less of you are impacted. We have determined that less than 5% of you are still using TLS 1.0 and 1.1 when you're making connections to us. So most clients, as long as you have built or updated your software since 2014, then most likely you are already defaulting to use TLS 1.2. So that is 95% of you are using TLS 1.2. But another kind of word of caution here is we also did another small pilot before we started this effort, reached out to about 30 of our larger customers again that we detected using TLS 1.0 to try to understand what was their use case. Why were they using this? Could they update? And what we found actually was the overwhelming majority of them were shocked, really surprised that they even had anything running in their environments that used TLS 1.0. So oftentimes this can be like forgotten test jobs, backup jobs. I think one case was one host got missed. So, just things to be aware of. Even if you think you're good, it is good to verify, right? The other point here is that all of them were very happy we reached out, happy we're doing this work. So again, there is overwhelming support. We hear from you, our customers, for us to go ahead and make these changes. So let's talk a little bit about the AWS shared responsibility model and how that relates to TLS. You're probably familiar with this model. As you know, you, our customers, are responsible for security in the cloud, meaning how you use the cloud, how you configure and secure your resources in the cloud. In context of TLS, what this means is that right now, you already have control to set the TLS versions you're going to use to connect. I will go into this in more detail in the later slides, but it's just important to know that you do have this control now to set the TLS version that your client applications will use. Now we, AWS as a service provider, are responsible for security of the cloud, meaning how we build and maintain the entire infrastructure for the benefit of all of you. Putting this into context of our TLS deprecation work, that means we control the TLS configuration on our service endpoints, and we will be updating those to remove TLS 1.0 and 1.1. If you're using TLS 1.0 and 1.1 to repeat, then you will need to take action, update your application to be able to continue to connect to our service endpoints. Now, when we say you need to take action and update, I want to be very specific about what we mean there. So we're using terms like API client, so let's just talk a little bit about what that is. To clarify what we mean, API client is your software application, program, service, or tool that is making programmatic calls to our API endpoints. Standard ways that you can create an API client that will call us is using any of our AWS developer tools, for example. So common ways are our AWS command line interface tool, our CLI tool, any of our AWS software developer kits, which we have available in many programming languages. You could also use any library, such as Bodo 3 for Python, a library that basically wraps API calls in a Python-friendly format. And then lastly, another common example of an API client is any browser or compute resource with internet access that can make authenticated HTTPS calls. For example, put or post calls using curl. So all of these are examples of API clients. Here I want to walk you through a TLS connection workflow so that we can fully understand the full picture and what part of this we are changing, what parts we are not. So in this case, we have a client that wants to make an API call, in this case, to Amazon EC2. They're doing a simple describe instance call. The client makes the API call, and first thing that happens behind the scenes is there is a DNS lookup performed, and the full HTTPS URL is discovered. Now, the fun part happens. The TLS negotiation begins, meaning the TLS configuration on the client will talk TLS to the endpoint in the cloud. In this case, a successful TLS negotiation is established, a connection is made. Now this is ensuring that there will be securely encrypted data passing back and forth between the client and the service, in this case EC2. The API call is processed by the service. It gets written to CloudTrail, and using that same secure TLS connection, the service returns the results back to the client. Now, the only thing here that we are changing is in step 2, is the TLS negotiation that happens during step 2. The rest of the calls, the commands, everything else on the service side is staying the same. Again, I've mentioned this before, but just to make sure we're clear, if your software does not support TLS version 1.2, then you will be impacted and not be able to successfully connect once we do the deprecation. An important call out we also want to make about our scope here is that when we're talking about API calls, it's quite common to think about your control plane calls, describe instances I noted before, but it's important to also remember that this does include any data transfer calls or data plane calls. So 4 of the most common services that you may be making data transfer calls to that we have here are Amazon S3, Amazon DynamoDB, Amazon SQS, and Amazon SNS. So as these are all in scope, includes your control plane and data plane calls, these also will be part of the deprecation that we'll be doing. Next, we're going to go over a bit more of the impact risk by walking through the TLS negotiation in more detail. So going back to that workflow, if you remember, I talked about in step 2, the TLS negotiation was the only thing that we're changing. So this is specifically focused on how that negotiation occurs. So in this case, we have, or you have, I should say, a modern API client that supports TLS 10, 11, and 12. And then the service, pre-deprecation, also supports 10, 11, 11, and 12. So by default, our services will select the highest mutually supported version. And this is where I go back to saying now you can control the TLS. As long as your client supports TLS 1.2, TLS 1.2 will be used for that connection. After deprecation, you have not changed anything in your client here. We have removed 1.0 and 1.1. We've got a modern client. So great, successful TLS 1.2 connection happens again. Couple points here is this all happens transparently for you. Nothing you need to do with a modern client. You're able to connect using 1.2. You also may notice that you did not have to remove 1.0 and 1.1. So you don't technically need to remove that. And also want to call out that AWS does have anti-downgrade protection, meaning that a malicious actor, we have measures in place to prevent a malicious actor from downgrading your TLS connection to a lower version. Many of you may be subject to compliance regulators or authorities that don't often deal well in nuance, as you're aware. So while you do not have to remove TLS 1.0 or 1.1 from your clients, this could be a good opportunity to simplify and just make it easier to get past those audits, right? So taking the same case with an obsolete API client, this time the client only supports TLS 1.0, the server supports 1.0, 1.1, 1.2, and a successful connection happens. But here's where the problem lies. We've now completed deprecation. Our endpoint now only supports 1.2, and this connection is going to fail. This will be a hard fail. This is a situation we don't want any of you to be in. One of the primary reasons we're doing this presentation today, and a little bit later, Daniel will go in his slides on how you can verify this and also update your clients. Many of you may be wondering about TLS 1.3. So the good news is, yes, we are adding 1.3. We've already started, in fact, we have some services already supporting TLS 1.3. KMS, Pinpoint are two that come to mind. We'll be adding more in the coming months. And the also good news is there's nothing you really need to do, again, if you have a modern client. It will just happen automatically. So in this case, this was before we add 1.3, you have a modern client that will support up to 1.3. 1.2 connection happens. Once we add 1.3 in the endpoint, just automatically you will make a 1.3 connection, have those performance and security benefits. Again, nothing you need to do. Going back a little bit, just to tie this back to that workflow that we saw before, focusing just on the negotiation, this is just the client hello, part of the TLS negotiation. Modern client supports all the way up to 1.2. The server responds, I also support 1.2. Let's use 1.2, a successful TLS 1.2 connection. Again, with an obsolete client this time, the poor old client only supports TLS 1.0. The server supports TLS 1.2, and this is going to fail. So at this time, I'm going to hand over to my partner, Daniel. He's going to cover with you how to know if you're impacted and what to do if so, some advanced scenarios, and he'll walk you through the demo. Thank you, Daniel.
Thank you, Janelle. All right, great to meet everybody here. I'm Daniel Salzito. I'm a security specialist, technical account manager in our worldwide enterprise support team, and I'm very excited to talk to you about this project because once it's complete, it will ensure that everybody gets the benefits of modern TLS in their AWS environment. So, as Janelle's explained, if you currently have API clients that are making TLS 1.0.1.1 calls today, or if you're not sure if you have them, there's a danger of impact. So you need to go and make sure that you know if you're impacted, and if you are, you're going to need to take some action to resolve that. So we've got a very simple 3-stage plan for you to do that. So the first thing to do is to monitor for your AWS notifications. Now you should be doing this anyway, it's an operational best practice, but we're going to be sending out some notifications specific to this project. The second thing to do is to analyze your API calls. So those calls you're making to your services, even if you don't get a notification from us, I'll show you how to do that. We've got some information there that's going to be very useful to you. And then lastly, but probably most importantly, check your clients, because the client is, at the end of the day, the thing that's making the call and that may need to be updated. So I'm going to go through those in a bit more detail, and then we'll talk about the actual actions you may need to take. So I mentioned notifications. This is what one of the notifications will look like. We actually sent the first batch of these out about a week ago, and we're going to be doing this continually on a rolling basis over the next 11 months as we get through this project. So if you currently are not sure who is monitoring your personal health dashboard for notifications, you need to know, and you need to get that done. It will also get sent to an email address, the registered email address, just like any other service notification. So if you get one of these, you need to take action on it. If you don't get any of these, it's a good indicator that you don't have this issue, but it's not the only thing you have to do, unfortunately. Because this is a best effort. We are using our back-end logs to find your connections, but we can't guarantee getting each and every single one, especially if your calls are very infrequent, or if you have created, say, a public S3 bucket with unauthenticated access. We can't always track those. So that's the first thing to do, to be looking out for this. The second thing to do, and you can do this in parallel, you can do this right now, is to go into CloudTrail and look in your calls for TLS details. So if you haven't seen this before, you haven't been into CloudTrail lately, we added this section, I've blown it up here, this TLS details section. Now this output is supported by about 50% of our services right now. There's a link on the screen, we've got a public documentation page. We're rolling out support, trying to get it to every single service as quickly as we can. And this gives you the exact version of TLS that was used, as well as the Cypher suite, which may be useful to your compliance teams. So in this particular screenshot here, you can see TLS v1 was used. Now, I'm going to emphasize this, I'm going to say it several times. Anytime you see TLS v1 in a technical document, that means 1.0. Not any version of 1, not 1.0 through to 1.3, it means only 1.0, very important. The other information on here, when we did this project the first time, as Janelle mentioned, for our FIPS designated endpoints, when we worked with our customers and they had to track down the couple of clients that were still making TLS 1.0 calls, what we found is these two pieces of information in the CloudTrail entry were the most useful. The source IP address, now that'll be the public IP address the connection came from, typically a NAT, a proxy gateway, a firewall. And the second one, the user agent, that's provided by the client actually making the call, the actual piece of software making that call. If you've never seen a user agent string, it's in a key value pair format, so it's a set of data divided up, key value divided by a slash, and there should be a space in between. That is under the control of the client. It can be very detailed or it can be very simple. This example here is from the AWS CLI, so it has three main sections: the name of the client, CLI, the version of it, then it runs on Python, so it's got the name and the version of the Python library it uses, and then it has the operating system as well, and even the fact that it's a 64-bit version of Windows. There's actually even some extra data down past it. You can see just about in that screenshot. That's an extension, not particularly relevant in this case, but some clients put that in there. However, it can also be much simpler. It can be a simple, a single key value pair of the absolute most basic. So that is typically what you're going to go looking for when you find that client. When we did this last time, the vast majority of our customers had basically one or two user agent strings for either an old build of a library, like an old build of Java or an old build of .NET, or a specific piece of software, like a user agent for some a piece of backup software or something that just never been updated for years. So that was the most common use cases we found. Now, most of our customers at AWS, we've got a lot of people running large, complicated environments. One of the things I'm not going to advise you to do is to try and do this one by looking at every single CloudTrail entry, in an environment where we have hundreds of accounts. So we've got a bunch of tools to do this at scale. Highly recommended if you've never looked at these tools. CloudTrail Lake, we just launched that this year. It's a great tool for going in and analyzing CloudTrail at scale across accounts and regions. Super easy to set up, no infrastructure. It's like 2 button clicks and you've got a SQL queryable data lake ready to go. CloudWatch Log Insights is also a great feature. CloudWatch, what you do is you go into CloudTrail, you go to your trail and say, push this to CloudWatch, and then you can do a bunch of stuff with CloudWatch. You can create metrics, you can create alarms, you can create dashboards. The health events are those personal health dashboards as well as other notifications from us. Hopefully, you've got an idea those are important and you can aggregate those. Using the AWS Organizations feature, you can aggregate those across your fleet of account so you can see those all in one place. And the health service itself, as well as CloudTrail and CloudWatch, they all have APIs. So if you are the kind of person who likes to build your own tooling, or you're working with other companies or third-party tools, there's APIs. You can go and extract what you need. Just show a couple of those in detail. So this is CloudTrail Lake. If you've never seen this, you turn it on, and we have published a sample query. This is on our blog, where you can go in there. This is a query specifically to look for old versions of TLS. In Log Insights, this is the same idea. Once you've got this turned on, you can go in there. It uses a slightly different, it's not SQL, it's a different query language, but again, you go in here and we've got a published sample query you can use. So the next step, once you've gone, analyzed your API calls, is to check your clients. A simple rule of thumb here is if you have clients that have been updated since 2014, they're probably going to need to be touched. You're going to need to go in and find those. If you've got that fleet of Windows 2008 servers or really old builds of Linux somewhere, that's probably what you're going to need to focus your effort on first. Now, the good news is, the inverse of that is if you have anything on this list here, then you should, most likely be okay. If you're using our tooling, if you're using our CLI tool, any version of version 1 from 1.20 upwards, any version of version 2 is going to be using TLS 1.2 by default, no problems. If you're using our SDKs, we've got those in a lot of different languages. Just make sure you've got a current version and you'll be fine. If you're a Linux shop, you're probably using OpenSSL for TLS. It's not the only library, but it's definitely the most popular one. 1.0.1 is the minimum version you want to have, so TLS 1.2 will be enabled by default. If you are a Windows shop, Microsoft Windows Workstation version 8 or Server 2012 R2 and upwards. Now, there is some limited TLS 1.2 support in older versions of Windows, but those versions are not supported by currently by Microsoft anymore. You're not getting support, you're not getting patching, so I wouldn't recommend using those, even if you can get TLS 1.2 to work. There are two other options you may need to be aware of. Hopefully you won't get into this, but we did have a few customers last time we had to do this. So the first is getting low level. Now I will show you this in my demo because it is a useful thing to do if you're just going in and actually want to see the traffic and troubleshoot directly. If you want to see exactly what version of TLS any outbound connection is making from your network, you can do that with a packet capture. If you're a security person and you're not a network person, ask your network team to help you. If you have a corporate network with a traditional outbound NAT gateway, you can see all the traffic in one place, or you can just do it locally, literally on a single system by capturing locally, which I'll show you later. The other thing you may want to do is analyze your infrastructure code deployment system. So one thing you've got to watch out for is regression. So let's say you go home, you check all your environment, you check your API calls, you check your clients, everything's good, everything's supporting TLS 1.2 today, but somewhere there's a little piece of automation that's going to deploy an old client with an old image in a certain circumstance, something that, something goes down and it replaces it. So you want to go and look through that and just make sure you don't have anything that might, accidentally deploy something that has been patched in place and reconfigured over time that you've forgotten about. So that's the plan to find out if you're impacted. If you are impacted, the most important thing you've got to take away from this is you've got to take some action. You can't just wait. You've got 11 months. It's a lot of time, but you don't want to be waiting until June next year, to the day that we announce that we're cutting this off to take action, because this can take some time. So again, 3 basic steps you need to do here. Update the clients. The clients are making the calls. That's what has to change. You may need to update underlying TLS libraries. Now, if you're using any kind of package management tool, when you do your update, that will usually happen automatically. If you are not using package management, if you're doing this manually, if you're hand building your systems, then you may have to do this manually as well. And check configurations and code. So I mentioned the automation codes, but also the actual configuration of your applications, because they may be making a modification to how your TLS library actually works. And I'll show you an example of that in just a minute, because that is something which is awkward. But the one other thing I want to tell you about this is not technical, is you have to have conversations. We found this last time. TLS is one of those plumbing things that everybody takes for granted, and it impacts potentially lots of different teams. So the security people, if you're security people here, you really care that you have the right version of TLS. But the actual people deploying the code that uses the API, that uses that TLS, may be your development team, there may be the operations team. You may have to talk to product teams if it means impacting your applications out in the world. So again, Do this early, do it often, start the process now, get everybody who is a stakeholder on board with this project so everybody knows exactly what's happening and when it's going to happen and what needs to happen and who needs to do it. Obviously at scale, you don't want to be doing this stuff by hand if you don't have to, so use appropriate tools to do this. If you are doing immutable infrastructure, and if you know what that means, then you should understand CI/CD pipelines and you should be pushing the changes out that way. However, if you've got a more traditional infrastructure where you're patching in place and you keep your systems alive for a long time, then you can use tools like Systems Manager. That's a great tool that we have. Systems Manager, if you're not aware of it, is not just for AWS compute resources. You can use it on premise. Just install our free open source agent on supported operating systems, and you can do remote run commands, remote push, remote inventory. You can see the exact version of every executable in library on every one of those compute resources in one place. You can even aggregate it as a great tool for doing this kind of project at scale. And I'm going to show you now, I mentioned that you can have specific TLS configuration. So this is kind of an awkward thing. If you're not a developer, you never thought about this before. We've talked a lot about the client, but you can override the settings of the client. So this is an example in Java. So let's say you've got a completely up-to-date version of Java, the most recent build of Java, you've got the most recent SDK for your application environment, and a developer goes in and does this. They set this system property. This will hard code every HTTPS connection to use only TLS v1.0, remember it says TLS v1, that means 1.0, or v1.1. It will never be able to do 1.2 or 1.3 with this configuration, even though your system supports it. So unfortunately, there are not just multiple languages. In most programming languages I've looked at, they can have 2 or 3 different ways to achieve this same thing, unfortunately. So this is something where I said you've got to talk to people, you've got to talk to your developers, you've got to have them search their code bases and make sure you don't have configurations like this. And if they do, those configurations need to change. Most typically, again, if you've got an old environment that's like, more than 6-7 years old, somebody in the past may have put a configuration in because they thought, there was a compatibility issue with TLS 1.2 and they wanted to make sure they weren't affected by that. That is not the case anymore. You should be able to eliminate anything like that. All right, so I'm going to talk about a couple of advanced scenarios that you may come across, and it's also a great way to kind of crystallize exactly what we're doing here technically, and then I'm going to show you a quick demo of troubleshooting this on a real-world system. So I want to emphasize the difference between a direct and an indirect API call so you understand exactly what we're talking about. So in this scenario here, this architecture, you may have built an application, so a mobile application, an IoT device, a smart device that's out in the world. And what you can do, if you choose to, is you can have that device get some credentials and make an API call to an S3 bucket and say, push a bunch of log data, once a day, once every couple of hours, whatever your application is. In this first scenario here, the API client is that mobile device, that IoT device, that smart device. So that device has to support TLS 1.2 once we complete the deprecation project, or these connections will start to fail. So that is very important. If you're doing this kind of thing, if you built this kind of application, you need to make sure that you know that those mobile devices have that TLS 1.2 support. If those mobile devices have one of our SDKs on there, you can go and make sure it's up to date, but you have to make sure the underlying TLS library does support 1.2. Now there's a second kind of architecture where you've built a custom API. So you've done this, you've still got those same mobile applications devices out in the field, but now you've gone in and you built yourself a front end using one of our tools like an application load balancer. So as Janelle mentioned, we are not changing that. Application load balancers, CloudFront distributions, API gateways, those services have user configurable TLS settings. If you've never noticed it, you may just be using the defaults, but you can go in there and choose from a set of predefined TLS configurations with the version of TLS 1.0 supported if you want, and the cipher suites. You can choose from a list of cipher suites. So if you are using this right now, and then you pass that connection through to a back-end EC2 instance, and then the EC2 instance then stores that data in the S3 bucket. Maybe it does a bit of manipulation on the way, doesn't really matter. In this scenario for TLS, your mobile clients, they're completely under your control. They are not going to be subject to the deprecation because the connection they make to that application load balancer is also under your control. We are not touching that. So if you're doing this right now today, this will continue working exactly as it does. The ALB will typically make another TLS connection to the back end, to the EC2 instance, and then that EC2 instance will have some code on it, and that is the only thing that will be subject to this deprecation project. So only the code running on that EC2 instance that's making the API call to the S3 bucket, you'll need to check supports 1.2. Now, the other reason I'm showing this architecture is this second architecture is a potential fix. If you have that first architecture and you know you've got a bunch of smart devices out in the field for your product and they cannot be updated to support 1.2, the underlying libraries, the underlying firmware, even the underlying hardware can't support it, you could potentially, but you can at least push a software update to them. You could potentially migrate from scenario 1 to scenario 2. You could stand up your own custom API gateway, change the software to point at that gateway, and then make sure that the back end of that environment is supporting 1.2, and you'll be able to fix that. So, 2 more scenarios I'm going to show you here. This is for cross-account access. So we mentioned early on that unauthenticated calls can be used, but this scenario here, this is an authenticated call you may be doing right now. So the scenario here is you have some secrets in an account B, you're the account owner of account B, and you're sharing them with account A. And there's 2 ways to do this. One is for a resource policy for services that support that. So that's what I've got in this scenario here. I've created a policy for my secrets, and I've said allow account A to call that. So the API client, in this case, is account A. That is who is actually making the call to Secrets Manager, and when it makes that call, it will be recorded in CloudTrail of account A, and if you've never gone looking for this, if you've never done cross-account sharing, there's actually 2 entries in CloudTrail you need to care about, an account ID and what's called a recipient account ID. So when you make that call, if account A's client is using TLS 1.0, then it's going to be subject to deprecation. That could potentially fail. Now, account B will see the Secrets Manager API call as well. The recipient account ID will change. So the important thing here, the risk is if account A is using 1.0 after deprecation, these calls will start to fail. Now, account B, you're the owner of account B, you cannot fix that. You cannot fix it for account A. You can just know it's happened. You might get the notification, you'll see it in CloudTrail, but you cannot reach out and change account A's client. So you're going to need to talk to the account A's owner. If you shared a resource with them, you must have some sort of communication, hopefully, and you're going to say, hey, we are detecting, we've been notified by Amazon that you're using TLS 1.0 in your client when you get the secret, and you need to fix that or it's going to stop working. So a second scenario, this is the exact same risk, the exact same issue. The only difference is, and I'm just including this for completeness, is we're going to use an IAM role instead of a resource share. So this is a very flexible system. This is generally considered the best practice is to get a temporary STS token by sharing the role with account A, and then the role has a policy that allows access to the secret. The only thing that's different in this scenario is there's an extra API call. So you have to do the assume role call first, and then that will show up in both accounts, and the Secrets Manager API call itself will now only show up in account B. So again, for deprecation, there's that risk that if the client in account A does not support 1.2, that this is going to fail. But there's also the second call that has to make that IAM call, so both the call to IAM and the call to Secrets Manager have to support 1.2. If they don't, they'll both fail. And just be aware that it's possible in some complicated environments there'll be 2 different clients. One client gets the STS token, and then another client actually interacts with the Secrets Manager, maybe a totally different SDK or different programming language. So there are 2 different calls you have to watch out for in that environment. All right. So now I'm going to do some demo, and I'm going to show you how this works. My laptop wakes up. Okay. Switch my input, and hopefully everybody is seeing the browser screen. All right, so, no, go away. I just clicked off the console. Okay, so in this account I've got set up here, I'm starting off in my health dashboard. So this is the first step. I got one of our health notifications. Let me scroll down. So this is the notification that you get. It's marked Security TLS Deprecation Notification. It has a bunch of information and a link to our blog there. And then because this is a real call that I made, you can go to this Affected Resources section. Now in the Affected Resources section, right now what we're able to do is send you a set of simplified data. This is basically the data that you'll see in CloudTrail, but it's simplified a bit because we have to do this at scale. So the most important information we're getting out of this is, firstly, it's in the US East 1 region, and I can see from the second data entry that this is the EC2 service. And then the third data entry is telling me the actual API call that I made. It was describe instances, and it's telling me it's TLS v1, which means TLS v1.0. It tells me I did it one time in the time was detected, and then this last part, this is the user agent string. Now, I mentioned that user agent strings are quite variable. This one is about as short as you can get. If anybody here is a Python developer, they may be looking at this and say, Python-requests. That's the request library, a common Python library that's used to make HTTPS connections. So it says it's it's Python-requests /2.28.1. That does not mean it's Python version 2.28, which would be pretty old. It means it's actually the version of that specific library. So that's my starting point. I got one of these notifications. So I know that I'm looking for describe instance calls in EC2 in US East 1. So now I'm going to go into CloudTrail. I'm going to filter this down. I'm going to see if I can figure out, maybe a bit more details about where this is coming from. Oh, and I must have typed that wrong. All right, so I've got a bunch of describe instances calls. They are all coming from the username that's an instance ID. So that tells me I've got an EC2 instance that's making these calls. It presumably has a role or credential on it that allows it to make the calls. And one thing I want you to note, you're doing some analysis, you look at that, if you can see, every one of those calls is exactly 5 minutes apart. So that's a little hint to me that this is probably some sort of automated process. So I can drill into one of these, I can pull this up, obviously all the normal CloudTrail data is here. I can see the fact that this is coming from a role that's assigned to that instance, so it's not an individual user most likely. And I can keep scrolling down here in the TLS details section. I can confirm, yes, this is TLS v1 that is being used to make these calls. So I went ahead and set up a CloudTrail Lake. One thing I want to note about CloudTrail Lake is an awesome feature, but you have to turn it on before you need it. So when you turn it on, it will not go through and analyze your previous CloudTrail data. So don't wait until you get that PhD notice from us. If you want to use this feature, if you turn it on now, you'll be able to start searching data straight away. So I've got a query here that was set up. Hopefully that's legible. This is very similar to what you see in our blog. It has a date range in it, so because you might have a lot of data, you don't want to necessarily see a ton of that. You can run that. It usually runs pretty quickly. And let me scroll down to the results. And here, so I can quickly do this. I could run this, there's an API for this. I could dump this out if necessary. I can see all of those calls. Obviously the columns here I've chosen it's SQL, so you can put every single piece of data in there if you wanted, or just keep it very simple to just show me all the TLS v1 calls and the name of the call. So that's Data Lake. The other thing that I did is I configured the CloudWatch log integration for CloudTrail. So you can see here the CloudTrail trail itself, that's my log integration. And if I go into that, I set up some metric filters. So this is a very useful way if you're searching for this at scale. So the metric filter there, I hope it's legible, is this filter pattern, which is $.TLSDetails.TLS version equals quotes TLS v1. So that will show me any v1.0 call. I'm not using a wildcard, I'm specifically using quotes there because I need to match it exactly. By the way, we haven't mentioned this, I should mention it. TLS v1.0 is the most likely type of deprecated call you're going to see. TLS v1.1 was never very popular because by the time it came out, a couple of years later, v1.2 came out, and almost every client that can do 1.1 could do 1.2. So you'll very rarely see 1.1 traffic, except we learned last time we did this for monitoring agents. So we found last time there was a class of like security agents that are scanning and just seeing what versions of TLS could I connect to in this environment and creating compliance reports. So every single actual 1.1 call we ever saw last time was just coming from a scanning agent. So, but for completeness, you do need to check that. So once you have this configured, you can create a metric, and then it's CloudWatch. So you can go in and look at the metric. You can look at the data over time. You can create alarms on this. Look at that 12-hour period. Oh. Turn that on. There we go. So these are all the TLS 1.0 calls that were made in my environment in that last 12-hour period. And if you're familiar with CloudWatch, you know how to use this at scale. You can create an alarm, and then when it triggers above the threshold, you can have it send you a notification, you can have it send you a page, a Slack message. One piece of advice I would give everybody is don't do active notifications right off the bat. If you're an operations person, you're thinking, oh great, I'm gonna go home today and turn this on and start paging people, I wouldn't recommend it until you've at least looked at the data. Because what you don't want to do, you could have thousands of TLS 1.0 calls happening right now, and you don't want to start sending out thousands of pages on each and every one. That would generally be unpleasant. So do a first pass, get an idea of the impacts you have right now. And the other great reason, once you've done that, for setting up something like alarming is to watch out for regression. So I mentioned this earlier, you can go home now, you can check this, you can say, okay, we're 100% TLS 1.2 in our environment, great. This project is running for the next 11 months. The cutoff date is June of 2023. So at any point in that 11 months, if somebody in your account or your AWS organization were to spin up some resource, some old resource, find some old image that for whatever reason they need to run that was using TLS 1.0, that could happen tomorrow, it could happen next month, it could happen 6 months' time. So you do need to monitor for this over time. Another cool thing that you can do is the contributor insights. So you can actually set up a rule like this where you actually, if you just want to see all of the TLS calls and make sure that most of them are 1.2, I did this earlier, so you can see the vast majority 1.2, but I do have some TLS 1 in there. That's under contributor insights here, and that's the same basic concept. I just put in a filter for all versions of TLS. All right, so I know I've got a problem in my environment. I know I've got TLS 1.0 calls coming from this instance. So I'm going to go ahead and remote into that instance and have a look and see what might be doing that, see if I can fix it. So I am going to use the Fleet Manager, Feature Assistance Manager to remote desktop in. This is nothing to do with TLS, but it's one of my favorite tools because it means you don't have to stand up any kind of bastion host or remote desktop gateways. If you want to get a nice GUI environment, you just have to give it a key, get this configured, same key you'd use for EC2 connections, and I can go right in here and get a nice desktop. Okay, so let's go ahead and make that full screen. All right, so this is a Windows desktop. This is, I believe, a 2019 build. It's entirely up to date, but somehow I'm still making TLS 1.0 calls out of it. So I am going to show you Wireshark here. If you have never seen Wireshark before, or if you've heard of things like network packet capture and it terrifies you, it did me, I'll be honest, when I first started doing this kind of engineering, but it is a very, very useful tool if you ever have to troubleshoot TLS, because it enables you to see what's really going on at the packet level. Now, when you first use a tool like this and you just say start packet capture, you get a bunch of data will start scrolling up the screen. It looks very confusing. The good news is you don't have to look at all of that stuff. What you're going to want to do is filter it. And for this project, there's really only one thing you want to do. I've got a filter set up here. Oh, come on. The mouse will cooperate. Go apply this filter. So this filter here is using a property of the packet itself for our benefit. So when you make a connection to a modern TLS server these days, it passes through something called a server name, which enables you to filter down, enables the server to know exactly which domain you were trying to connect to when you made that call. So I know that my calls are going to the EC2 service in US East 1. So I put in a filter that says, tell me any packet where in the handshake it's making, the server name contains EC2.US East 1. Now, as soon as I turn that filter on, my traffic's disappeared. There's nothing going on right now. And I'm going to sanity check that. I'm going to bring up the command line here, and I'm going to run a CLI command. I call describe instances, and you'll see in just a second, there goes my outbound packet. So I've gotten rid of all the extraneous stuff. The only thing, once you start troubleshooting this, you generally care about is this first packet, the client hello. This is you making the outbound connection. If you made that outbound connection after deprecation with TLS 1.0, there would then be an error, there would be a connection reset immediately after that, but you would still see that outbound packet because your computer would still be trying to make that connection. So here's the connection outbound. And Wireshark is one of my favorite tools for this because you can go down here, it's got a whole section here for transport layer security. You can drill into this and you can see every part of this that matters. You can see the protocol that's being used. You can see all the technical information. Very, very little of this is really going to be necessary for this project. All you really care about is what version was used when I made that outbound call. So now what I have to do is track down what is doing that, because it's not my command line. So as we saw in our CloudTrail analysis, these calls are being made every 5 minutes. So it's a good bet that there's some process here that's running on a timer. So in Windows, that would be task schedule usually. On a Linux system, it would often be cron. So I'm going to go in here and have a look and say, oh, what's this check EC2 instances? There's a program running here, demo.py on my desktop. I wonder if that might be the culprit. So let's have a look at demo.py. So this is a Python program. I'm not putting this up here to demonstrate my mad skills as a Python programmer because they do not exist. Every time I get stuck, I have to ask my son. But this is a piece of sample code I stole from our website. This is how to write an API call to an AWS service in raw Python without using our Boto3 library, which is frankly much easier. The reason I'm using this is because I'm using just the basic Python. I added in this little piece of code here, this TLS adapter code. So this code is not standard. This code enabled me to manipulate the version of TLS that this Python client is using. Now, hopefully, if you use default configurations, you wouldn't usually do this, but it does happen. People go in and hard code stuff. Maybe somebody had a compatibility issue once in the past. Maybe somebody got told, oh, you need to be using TLS 1.2, and they thought TLS 1 was any version of TLS. So this line here, where it says SSL protocol underscore TLS v1, that is the problem. That is telling this client to only use 1.0 because it just says v1. So to sanity check that, I'm going to go back to the command line. Let me get the Wireshark back up. Go back here to the command line. So what I'm going to do, hold on a second. Now send a control, get rid of the code. Okay, so I want Wireshark. Go to the command prompt, close out of that. Okay, so I want to run that Python code directly here, and it's doing the same thing, it's doing describe instances, but now you can see, as soon as I hit that, run that code, you can see another TLS 1.10 packet came up there. So we know this is the right culprit. So the good news is, in this particular case, this is super easy to fix because the version of Python on my laptop is up to date. I know it supports 1.2. I know I can do it from the operating system level. The CLI is working. For this particular programming language, the syntax is 1_2, not 1.2. That's just the syntax it's using. Every programming language is going to be different. So obviously you've got to find the right, this is again, if you're a security engineer, you don't know Python, you've got to talk to your developers. You can't necessarily do this yourself. So I'm just going to hit save on that. Get the packet capture back up. Go back here, run that Python again, and now we should see it making that call, and now it's using 1.2. So that's a very simple example, but this can happen. Obviously, I went and did this manually, directly on the box. If you're doing this at scale, hopefully that Python code will be checked into a code repository, and you can search that, find it, update it, test it, and push that out to your fleet. All right, so let us switch back. All right, so let's summarize everything we've seen. So firstly, we've got a lot of resources available to you. Obviously, you come here to this presentation today. So if you want to read the blog about the TLS deprecation project itself, we published this last month. If you've never read it, we've got a bunch of advice there. We've got a blog on using CloudTrail Lake, that search that I showed you, that a couple of my colleagues put together. And we have a blog, if you've never had to do this, if you've never thought, how is SSL TLS configured in my operating system if you're using an Amazon Linux build, we've got a blog about configuring that specifically there. All right, so what do you need to take away from this? So the good news is everybody, every customer is going to get this modern TLS configuration automatically. We're going to push this change out on the back end of AWS. You're all going to benefit from it. So that's, that's the really good news here. You do have to watch out for these notifications. So we're going to be sending these notifications. We're going to be sending them out over this 11-month period. As I mentioned, regression can be an issue. So if you've got no notifications today, great. But you need to be monitoring them. You should be doing this anyway. Operational best practice, regardless of the TLS deprecation, you should be monitoring your personal health dashboard notifications and taking action where necessary. And if you are impacted, you must take action. You must talk to the relevant stakeholders. This is not, unfortunately, often a one-size-fits-all solution. There's going to be code changes, there might be platform changes, there might be infrastructure changes, there might be product changes, there might even be hardware changes needed if you are impacted. So talk to the right people, start that conversation, and talk to us. If you are an AWS customer and you have a support contract, open a support case if you need to, and we'll get the right technical people engaged on our side. You can use, if you don't even have a support contract, you can use our repost forum. If you have enterprise support, you can talk to your TAMs and your account teams. We love to talk about this. And myself and Janelle will be more than happy to continue this conversation afterwards. Just come and see us over here on the side of the stage. And that's everything we have for you today. You can also contact us on LinkedIn, and do please complete your surveys today. We love to get your feedback. All right. Thank you, everybody. Thank you, Janelle.